The next type of factoring that we are going to talk about is factoring quartics. So again, we're always checking for greatest common factor. And then if we can factor a quartic equation, it has to be missing the cubic and the linear term. So it has to be in this pattern where we have x to the fourth, x to the squared, and then a constant. So if it's not in this pattern, or if it's, we can also exclude this one, we can't factor it. So it has to be in this pattern for it to work. And if it is, then we're going to factor it just like a quadratic equation. So the only difference will be is that we might be able to continue factoring since we'll have quadratic terms. All right, so looking at 15, it's missing both the cubic and the linear term. So I'm trying to find two numbers that multiply to be 9, add to be negative 10. So we would choose a negative 9 and a negative 1. And then this first term I'm going to split as x squared and x squared. And now we need to decide if we have the difference of squares. And both 9 and 1 are perfect squares, so that means that we can actually keep factoring for this one. So this one, two numbers that multiply to be negative 9, add to be 0, would be a positive 3 and a negative 3. And then two numbers that multiply to be a negative 1, add to be 0, would be a positive 1 and a negative 1. So this is our final factored answer. Our next one, same thing. So we have a quartic. We're missing the cubic and the linear term. So we're trying to find two numbers that multiply to be 36, add to be 13. So that is going to be a positive 9 and a positive 4. And then we split the first term as x squared and x squared. And since these are the sum, we can't factor any further. So this would be our final factored answer. All right, and then the next one, so same thing. We're trying to find two numbers that multiply to be negative 8, add to be negative 2. So we would choose the factors negative 4 and positive 2. And again, we split that first one as x squared and x squared. And then on this group, this is the difference of squares. So two numbers that multiply to be negative 4, add to be 0, would be x plus 2 and x minus 2. And then this one we can't factor because that's not the difference of squares. So we're just going to leave that one. So this would be our final factored answer. All right, next one. So when we split this, the first term we would have to split as 2x squared and x squared. And then the only numbers that multiply to be 3 are 1 and 3. So now we just have to figure out where to place them. So let's try a minus 1 and a positive 3 and see if we pick the right order. So again, we're going to check the inside and the outside. So if we multiply 2x squared times 3, that's going to give us 6x squared. And then negative 1 times x squared is a negative x squared. So if we add those, that's a 5x squared, which is our middle term. So we chose the right positioning. We don't have the difference of squares on either of these. So this is our final factored answer.